The ocean, a hidden planet. The ocean covers most of the Earth's surface, but it remains the least explored environment. Beneath the thickness of the water, pressure increases to levels that the human body could not withstand for a second, and yet life exists there. Slow, strange, alien to our understanding. The ocean is an archive. It holds the history of the climate, the movement of continents, and traces of catastrophes. Darkness in which there is light. In the absolute darkness of the ocean depths, life has learned to create light. Bioluminescence is used for communication, hunting, and camouflage. Sometimes entire patches of water begin to glow as waves move, as if the planet itself is reacting to touch. Underground oceans, beneath the Earth's surface, there are vast volumes of water. This water does not flow freely. It is trapped inside minerals, compressed by pressure, heated by temperature. The amount of this water may exceed the volume of all the oceans we see on the surface. Beneath our feet lies a hidden world about which we know almost nothing. The core that creates a shield. At the center of the Earth is the core. It consists of metals and is in a constant state of motion. This movement creates a magnetic field, an invisible shield that protects the planet from the solar wind. Without it, the atmosphere would be carried away into space. Water would disappear. Life would not have arisen at all. Magnetic reversals. The Earth's magnetic poles are not fixed forever. They drift. Sometimes they switch places. During these periods, the magnetic field weakens. Cosmic radiation intensifies. The Earth has experienced this many times, and each time, it continued to exist. Time on Earth is not uniform. Time on Earth flows differently. On mountaintops, it goes faster than at sea level. Satellites take this difference into account. Without these corrections, navigation systems would cease to function. Even time on our planet is unstable. The Earth is slowing down. The Earth's rotation is gradually slowing down. Days are getting longer. The calendar has to be adjusted. Millions of years ago, days lasted less than 20 hours. The Earth is aging, and this is reflected even in time. Life as an accident.
Close your eyes and imagine emptiness, not darkness. Emptiness itself. There is no up or down, no sound, no direction. This is the emptiness in which the universe was born. Approximately 13.8 billion years ago, there was no space, no time, no distance. There was no where, there was no when. There was only a moment in which everything appeared at once. We call this the Big Bang, but it was not an explosion in the usual sense. There was no center, there was no edge. Space itself began expanding everywhere simultaneously. Even now, it continues to expand. Galaxies are not flying through space. Space itself is stretching between them. The light you see in the night sky is a message from the past. Some of the stars people look at no longer exist. They died thousands, millions, or even billions of years ago, but their light is still traveling. It does not know that its source is gone. This is the essence of the universe. It never reports events immediately. The sun around which Earth orbits is 8 light minutes away. If it disappeared right now, you would still feel warmth. You would still see daylight. You would still be alive for exactly 8 minutes, and then gravity would vanish, and Earth would drift into cold darkness. Gravity travels at the speed of light. Even death in the universe has a delay. Inside the sun, millions of tons of matter disappear every second. They are converted into energy. That energy keeps the star from collapsing. Stars are a balance between the desire to collapse and the inability to stop. When this balance is broken, a star dies. Some die quietly. Others die so brightly they can be seen across the entire universe. A supernova can, for a brief moment, outshine an entire galaxy. It is death that illuminates space. Every atom of iron in your blood was created this way. It was forged in the final seconds of a star's life. You are literally made of the remains of dead suns. At the center of our galaxy lies an object whose mass exceeds that of the sun by millions of times. It does not shine. It does not reflect. It bends space itself. Time flows more slowly near it. If you were near a black hole and looked at a clock, it would tick differently than on Earth. For the universe, time is not absolute. It is a variable. Black holes do not suck everything in. They are patient. They wait for something to come too close. Where the event horizon ends, time stops making sense. We do not know what happens beyond it, and perhaps we never will. In space, there are planets where molten glass rains from the sky. There are worlds where winds reach speeds of thousands of kilometers per hour. There are planets that orbit their star faster than they rotate on their own axis. There are worlds where night lasts for decades. But there are others, those we will never see. The universe is not silent because there is nothing happening. It is silent because there is no air to carry sound. Every explosion, every collision, every violent birth of a star happens in perfect silence. Cosmic catastrophes unfold without noise, without witnesses. Space is not empty. It is filled with radiation, with particles, with invisible fields stretching across unimaginable distances. Even the emptiest regions of the universe are never truly empty. Between galaxies lies dark matter. We cannot see it. We cannot touch it. But without it, galaxies would fly apart. Dark matter does not shine. It does not absorb light. It reveals itself only through gravity. Everything you see, stars, planets, gas clouds, galaxies, makes up less than 5% of reality. The rest is invisible. Most of the universe is something we do not understand, and dark energy is even stranger. It is the force driving the expansion of space itself, not slowing it down, speeding it up. The farther a galaxy is from us, the faster it is moving away. Eventually, distance becomes a barrier no signal can cross. Time will isolate galaxies from one another. Civilizations, if they exist elsewhere, will one day look into the sky and see only darkness. They will believe they are alone, not because they are, but because the universe has erased the evidence. Our galaxy contains hundreds of billions of stars. Many of them have planets. Many of those planets exist in regions where liquid water could survive. Statistically, life should not be rare. And yet, the sky remains quiet. This contradiction has a name: the Fermi paradox. If the universe is so vast and old, then where is everyone? Perhaps civilizations destroy themselves. Perhaps they choose silence. Perhaps intelligence is brief. Or perhaps the universe is not designed for permanence. Stars are born in clouds of gas and dust. Gravity pulls matter together until fusion ignites. Light appears where there was none. For millions or billions of years, a star burns steadily. Then fuel runs out. Small stars fade slowly into white dwarfs. Large stars collapse and explode. The most massive collapse into black holes. Nothing lasts forever. Even protons, according to some theories, will eventually decay. Matter itself may not be eternal. Time erodes everything. If you could observe the universe far into the future, you would see galaxies growing dim, stars becoming rarer, energy spreading thinner and thinner, structure dissolving into randomness. This is entropy, the slow, unstoppable drift toward equilibrium. Life exists because the universe is not yet balanced. Order survives only because disorder has not finished its work. Every breath you take, every thought you form, every signal your brain sends is possible only because energy still flows. When energy stops flowing, complexity dies. The laws of physics do not care about meaning. They do not reward survival. They only describe what happens next.
The universe does not unfold in moments.
It unfolds in processes that last longer than any memory, longer than any civilization, longer than the idea of history itself, and everything you perceive as change is only a slow rearrangement of energy, following rules written into reality. At the moment of its birth, because stars do not rush to exist and galaxies do not hurry to form, they take hundreds of millions of years to assemble their spiral arms, their glowing cores, their vast halos of unseen matter, and during all that time nothing observes them, nothing judges them, nothing records their becoming, while gravity patiently gathers dust and gas into structures so large that light itself needs tens of thousands of years to cross them from end to end. And inside these galaxies, stars drift like embers in a cosmic fire that never crackles, never roars, never announces itself, because space remains silent even when creation is at its most violent. And this silence is not absence, but indifference, the indifference of a universe that operates without intention yet produces patterns so precise that equations written by human hands can predict the motion of objects billions of kilometers away, years before their light even arrives. And it is within this predictable chaos that planets settle into orbits, climates stabilize for brief windows of time, and chemistry is allowed to repeat itself long enough for complexity to emerge. Because life is not planned, it is permitted, and permission is granted only temporarily. As stars age, radiation changes, impacts occur, atmospheres escape, and worlds slowly drift out of the narrow conditions that allow them to host oceans, biology, and awareness, which means that consciousness is not a permanent feature of the cosmos, but a fleeting phase, a short-lived arrangement of matter capable of asking questions before entropy erases the conditions that made those questions possible. And even now, the universe is cooling, stretching, thinning, with every second locking in a future where energy becomes harder to gather, harder to concentrate, harder to use, until eventually, even the longest-lived stars fade into darkness, and the sky becomes empty not because something went wrong, but because this is the natural conclusion of expansion without limit. And when that time comes, there will be no final explosion, no collapse into chaos, no dramatic ending worthy of narration, only a gradual fading where motion slows, interactions cease, and reality approaches a state where nothing meaningful happens anymore. Yet all of this vast, inevitable progression began from a state so small, so dense, so extreme, that our current understanding of physics breaks down when we try to describe it, forcing us to accept that the deepest origin of everything remains unknown, not hidden by distance, but by the limits of comprehension itself. And still within that uncertainty, the universe produced stars, planets, chemistry, life, memory, and a mind. As time moves forward, the universe does not repeat itself. It only transforms, carrying the consequences of every interaction into the next state of reality, which means that the position of every atom, every photon, every particle is linked through cause and effect to the earliest moments of existence, forming an unbroken chain that stretches from the beginning of time to the present instant. And while this chain feels abstract, it is physically real, encoded in the structure of space itself, because the distribution of galaxies, the temperature of interstellar gas, and the faint background radiation filling the cosmos all preserve information about conditions that existed billions of years ago, turning the universe into a vast archive that constantly records its own past without intention or awareness. And within this archive, gravity remains the dominant sculptor, slowly pulling matter into filaments and clusters that resemble a cosmic web, where galaxies gather at intersections, like droplets forming along invisible threads. And this structure did not arise by design, but by inevitability, the natural outcome of tiny fluctuations amplified over immense spans of time, proving that complexity does not require guidance, only persistence, and persistence is something the universe has in abundance. Yet even persistence has limits, because stars burn fuel and fuel is finite. And as generations of stars live and die, they change the chemical makeup of galaxies, enriching them with heavier elements while simultaneously reducing the supply of raw hydrogen needed to form new suns, meaning that star formation will one day slow and eventually stop, not abruptly but gradually, as if the cosmos itself is growing tired. And when the final stellar nurseries fall silent, the remaining stars will continue to shine in isolation, separated by ever-increasing distances, until they too exhaust their cores and fade into remnants that no longer illuminate their surroundings, leaving behind white dwarfs, neutron stars, and black holes drifting through an expanding void. And during this era, the universe will appear darker, not because darkness has increased, but because light has become rare, spread thin across distances so vast that even the fastest signals can no longer bridge them. And at that point, causality itself becomes local, confined to small islands of matter, unable to influence or even acknowledge one another, turning existence into a collection of disconnected regions, each evolving alone. And if any form of life or intelligence were to persist into such a future, it would inhabit a reality fundamentally different from ours, a sky nearly empty, a cosmos seemingly small, unaware that once there were countless galaxies visible in every direction. Because memory does not survive cosmic expansion, only structure does. And when structure dissolves into uniformity, the story of the universe effectively ends, not with destruction but with forgetfulness. Yet right now because our intuition was shaped by survival on a single planet, within distances measured in steps and days, not light years and epochs. And yet, through mathematics and observation, we have learned that distance and space is also distance and time, meaning that every deep look into the cosmos is an act of archaeology, uncovering layers of reality as they once were rather than as they are now. And this creates a universe where the present is fragmented, where no observer ever sees the whole at once, only a mosaic assembled from delayed signals, each carrying information that has traveled uninterrupted for millions or billions of years, never slowing, never aging, until it meets a detector, an eye or a mirror, and stops, transferring its history in a single instant, while the source that created it may have long since transformed or vanished entirely. And this delay is not an inconvenience, but a fundamental feature of reality, one that ensures that the universe can never be fully known in real time, only inferred, modeled, approximated. And this limitation applies equally to the future, because while physical laws describe what can happen, they do not dictate outcomes in detail, leaving room for chance, instability, and divergence, especially in complex systems like climates, ecosystems, and civilizations, where small variations can grow into irreversible differences, meaning that even in a universe governed by strict rules, the path taken is never uniquely determined, and this balance between order and unpredictability is what allows novelty to exist at all, because without it, stars would never vary, planets would never differ, and life would never experiment beyond repetition. Yet this same freedom ensures fragility, because structures that can form can also collapse, and nothing in the cosmos is protected from time. Not mountains, not species, not worlds, not even the fabric of space itself, which continues to stretch, thinning energy and isolating matter with every passing moment, slowly guiding the universe toward a state where interaction becomes rare and change becomes minimal. And although this future is distant beyond comprehension, it is already underway, encoded in the expansion measured today, reminding us that the present is not stable but transitional, a brief configuration in an ongoing process that neither pauses nor accelerates for observers. And within this process, consciousness arises briefly, looks outward, and attempts to understand the system that produced it, knowing that understanding will always be partial, temporary, and incomplete, yet pursuing it anyway, because curiosity is a natural consequence of complexity, and complexity itself is one of the universe's most fleeting achievements. The scale of the universe is not something the human mind evolved to grasp. As the universe ages, it does not simply grow older. It grows more diluted, with matter spreading out across. The laws that govern the universe are remarkably simple when written down, yet endlessly complex in their consequences, because from a small set of constants and interactions arises everything from the fusion inside stars to the chemistry inside cells. And this simplicity is deceptive, hiding a reality where outcomes depend not only on rules, but on initial conditions so precise that even tiny differences in the early universe have led to entirely different cosmic neighborhoods billions of years later. And this sensitivity ensures that no two regions of space share the same history, even if they obey the same physics, meaning that the universe is unified in law, but diverse in outcome. And within this diversity, time acts as both creator and destroyer, allowing structures to form through gradual accumulation while simultaneously guaranteeing their eventual decay through entropy and expansion. And this dual role ensures that nothing remains fixed, that everything is provisional, including the very concepts we use to describe reality, because our models evolve as observations improve, replacing certainty with approximation, and approximation with revision, reminding us that knowledge itself is a process rather than a destination. And this process mirrors the universe it seeks to understand, dynamic, incomplete, and constantly adjusting. And while our instruments extend our senses across vast distances, they also reveal limits that cannot be engineered away, such as horizons beyond which information cannot reach us, or scales at which quantum uncertainty dominates, blurring the distinction between what is and what can be measured. And at these extremes, reality becomes probabilistic, described not by definite outcomes but by likelihoods, challenging the intuition that the universe must be deterministic to be comprehensible, when in fact uncertainty may be fundamental, woven into the fabric of existence rather than imposed by ignorance. And this realization reshapes the meaning of prediction, shifting it from certainty to expectation and from control to acceptance, because even in a universe governed by equations, not everything is foreseeable, not everything is avoidable, and not everything can be preserved. Yet within these constraints, the cosmos remains fertile, producing stars and dense clouds, planets and spinning disks, and complexity wherever energy flows long enough to sustain it. And this flow is the true driver of change, because without gradients, without differences, without imbalance, nothing happens. And it is precisely because the universe is unfinished that anything can occur at all, including thought, memory, and reflection, all of which are temporary patterns sustained by continuous energy exchange, destined to fade when conditions shift, but meaningful while they persist, not because the universe assigns them value, but because they arise naturally from the same processes that light stars and shape galaxies. If you could step outside of time and observe the universe as a whole, you would not see moments, you would see gradients, slow transitions from density to emptiness, from heat to cold, from structure to simplicity, because time inside the universe feels directional only to those embedded within it, while from a broader perspective it is simply another dimension along which change unfolds, and this change is not driven by intention, but by imbalance, by the fact that the early universe was uneven enough to allow gravity to amplify tiny differences into galaxies, stars, and planets, and once those structures formed, they became stages for further transformation, hosting nuclear reactions, chemical networks, and eventually biological systems capable of storing information and responding to their environment. And information is the quiet thread connecting physics to life, because atoms remember their bonds, molecules remember their configurations, cells remember their past states, and brains remember patterns long enough to predict what might happen next, turning raw causality into experience. And this ability to model the future, even imperfectly, is what separates inert matter from living systems. Yet this separation is temporary and contextual, because the same forces that allow memory to exist will eventually erase it, scattering molecules, breaking bonds, and dissolving organized systems back into simpler forms. And this is not failure, but completion, the natural endpoint of processes that require energy gradients to persist. And as gradients weaken across the cosmos, the conditions that support complexity become rarer, not suddenly but progressively, reducing the number of places where long chains of cause and effect can sustain awareness, until awareness itself becomes an unlikely event, confined to brief pockets of time and space. And this rarity does not make consciousness insignificant. It makes it precise, like a narrow resonance that occurs only under specific conditions, and those conditions happen to exist now, on this planet, around this star, in this galaxy, during this era, allowing a fleeting alignment where the universe can be examined from within, described using symbols, equations, and stories that attempt to compress vast processes into understandable forms, and while these descriptions will always be incomplete, they are not meaningless because they reflect real regularities, real constraints, and real histories written into the structure of space and time. And by tracing these patterns backward, we approach the limits of knowledge, regions where concepts like before and after lose clarity, where space and time merge, and where existing theories no longer apply, forcing us to accept that the origin of everything may never be fully articulated, not because it is mystical, but because explanation itself relies on frameworks that emerged later. Across the vast distances separating stars and galaxies, the same physical principles repeat without variation, ensuring that the universe remains consistent even as it grows more complex in some regions and simpler in others. And this consistency allows predictions to hold across scales, from the motion of planets to the behavior of light near massive objects, creating a reality that is stable enough to support long-term processes like stellar evolution and biological development, yet flexible enough to produce novelty. And within this balance, chance plays a subtle but decisive role, because while laws constrain what can happen, they do not dictate every detail, leaving room for fluctuations that can redirect outcomes in irreversible ways, especially when systems become sensitive to initial conditions. As planets cool, atmospheres evolve, and ecosystems adapt to shifting environments. And these sensitivities ensure that no two worlds follow the same path, even if they begin with similar ingredients, making the cosmos not a uniform repetition, but a branching set of histories, many of which end quietly without ever hosting observers, while a few develop the complexity required for perception, memory, and abstraction. And abstraction itself represents a significant transition, allowing systems to represent aspects of reality internally and act on those representations rather than on immediate stimuli alone, creating layers of causality where ideas influence actions and actions reshape environments. Yet these layers remain grounded in physical processes, dependent on energy, stability, and time, all of which are finite resources. And as resources change, the structures built upon them must adapt or dissolve, reinforcing the idea that permanence is not a feature of the universe but a temporary illusion created by slow rates of change. And when change accelerates beyond the capacity of systems to adjust, collapse follows not as punishment, but as consequence. And this applies equally to stars that exhaust their fuel, planets that lose their atmospheres, and civilizations that exceed the limits of their environments, illustrating that scale does not grant immunity from fundamental constraints. And still the universe continues to generate opportunities for structure wherever conditions permit, assembling matter into stars, stars into galaxies, and interactions into networks of cause and effect that briefly resist entropy before yielding to it. And this resistance is what defines eras of richness, moments when the universe supports diverse forms and dynamic processes, moments like the present, where energy gradients remain strong enough to sustain complexity, curiosity, and reflection, allowing minds to emerge that can look outward, measure the heavens, and recognize patterns that extend far beyond their immediate surroundings, even while knowing that this recognition will not alter the ultimate trajectory of the cosmos, but will exist as part of it. Beyond everything that can be measured, there remains a vast domain of uncertainty, not because instruments are insufficient, but because reality itself places limits on what can be known, and these limits are not barriers to be overcome, but properties of the universe, defining horizons beyond which information cannot travel and scales at which observation alters what is observed, ensuring that complete knowledge is not merely difficult but fundamentally impossible. And this impossibility is not a flaw in the structure of reality but a consequence of its depth, because a universe capable of generating complexity must also allow ambiguity, indeterminacy, and multiple possible futures. Otherwise, it would collapse into repetition, and repetition would leave no room for evolution, adaptation, or emergence. And so the cosmos balances precision with openness, enforcing strict laws while permitting freedom within them, a freedom that manifests as randomness at the smallest scales and as unpredictability in the largest systems, where countless interactions compound into outcomes that cannot be traced backward with certainty. And this is why, even with perfect equations, the future remains only partially visible, outlined by probabilities rather than guarantees. And within this probabilistic landscape, life navigates by approximation, making decisions based on incomplete information, adapting not to certainty but to expectation, which means that survival itself is an exercise in uncertainty management, refined over billions of years of trial and error. And this long refinement has produced organisms capable of modeling not only their immediate surroundings but abstract concepts like time, distance, and causality, extending perception far beyond direct experience. And through this extension, the universe becomes representable within itself, encoded in symbols, languages, and theories that compress immense processes into forms that can be shared, transmitted, and refined across generations, creating continuity where none is guaranteed by physics alone. And this continuity allows knowledge to accumulate even as individuals fade, forming a collective memory that briefly counters entropy by preserving patterns across time. Yet even this preservation is temporary, because no medium is eternal and no record immune to decay, meaning that all accumulated understanding exists on borrowed time, destined eventually to be lost as conditions change and structures dissolve. But loss does not negate existence, and impermanence does not invalidate experience, because value arises locally, within systems capable of recognizing it, not from cosmic endorsement, and the universe neither confirms nor denies meaning. It simply unfolds according to its nature, allowing meaning to arise where complexity permits. And in this way, significance becomes relational rather than absolute, grounded in the interactions between observer and observed, moment and memory, structure and change.